In this video, we'll talk about how to calculate the average atomic mass. But before we do that, we need to know what isotopes are. So here we have two lithium isotopes. We have lithium with a mass number of 6, and then lithium with a mass number of 7. So what that means is that in lithium-6, with a mass number of 6, we have 3 protons and 3 neutrons. And then in lithium-7, we have 1 more neutron. So 3 protons, 4 neutrons. But you'll see that on the periodic table, you're given an average atomic mass for lithium. It's 6.941. So the question here is, how can lithium have 0.941 neutrons? And here's the reason why. So here is the number of neutrons for each of the 100 lithium atoms randomly sampled from nature. So you can see that most of the lithium atoms are going to have a mass number of 7, but there's a few of them that have a mass number of 6. So that is why we have an average atomic mass here. You can see that it's closer to 7, but it's a little bit less than 7 because there are a few isotopes with a mass number of 6. So average atomic mass, again, is the weighted average mass of all of the atomic masses of the different isotopes in that atom. So we're going to go through 2 examples. So here's what we're going to do. You're given 3 different isotopes of chromium here, the mass number of 50, 52, and 53. And then you're given the percent abundance of each. So what we're going to do is we're going to take the mass number and multiply it by the percent abundance for each isotope. And then we're going to add all 3 of these numbers together. So when you do that, you get 5,205. And then last step is to divide by 100. And we get 52.05 AMU. A good way to check your answer on these is your number always has to be in the range of the mass numbers. So your range here of acceptable answers would be between 50 and 53. So our answer 52.05 fits right in there. And the units are AMU, which stands for atomic mass units, but we abbreviate it AMU. I want you to pause the video, try this example, and then I'll go through it with you. So in this example, we'll multiply the mass numbers that you're given. This is iron. There's 4 different isotopes of iron, and their percent abundances are listed here. So we're going to multiply mass number by the percent abundance. And we're going to add all of these numbers together. We get 5,592. And then last step is divide that number by 100. So we get 55.9, and units are AMU, atomic mass units. Remember to check your answer, make sure it's within the acceptable range. So the acceptable range is from 54 to 58, so our answer fits within that range.